formulas actually work. So remember, they'll be on your quiz tomorrow. They'll be on your test in Chapter 5. You just have to be able to apply them. So as you look at each formula, sine, cosine, tangent, they all look the same on the left. It's u plus or minus v. And what this is going to allow us to do with the sum or difference formula, because we're either adding two angles or subtracting two angles, is we'll now be able to evaluate the sine, cosine, and tangent exactly for angles that don't appear on the unit circle. So like when I ask you to do exact values of the trig ratios for specific angles, I usually can only ask you the angles that you know from the unit circle. 30, 45, 60, 90, 135, 120, all of those, you can use the knowledge. Cosine is equal to the x-coordinate, sine is equal to the y-coordinate, tangent is equal to y over x, and they're reciprocals. Okay. But I can take two angles from the unit circle, so let's say I pick 45 and 30, and I could subtract 45 and 30, and that would allow me to do the sine, cosine, and tangent of 15 using these formulas, sum and difference. Or I could take 45 and 30 and add them, and I can also do the trig ratios for the angle 75 degrees. So as long as the angle that you want to find can be made up of angles that exist on the unit circle, you can apply the sum or difference formulas and you can evaluate them exactly. Now, notice that they all look the same on the left, like aside from the trig ratio, the u plus or minus v, but over on the other side, this is where the formulas differ. So you'll just follow whatever formula you want to use depending on the trig ratio. Pay attention to these plus or minus signs. So like for the sine formula, it says the sine of u plus or minus v equals, and then you do the sine of u times the cosine of v, and it says another plus or minus. So it looks just the same. It won't be both at the same time. It will just be one of them. So if you're doing the sine of u plus v, then you should use the plus on the other side. If you're doing the sine of u minus v, then you should do minus on the other side. When you're doing cosine, notice how this changes. It says the cosine of u plus or minus v, and then on the other side in the actual work, instead of plus or minus, it says minus plus. So that means I'll write one example down here for cosine. If I was doing the cosine of u plus v, then I would do the cosine of u times the cosine of v minus the sine of u times the sine of v. So when you see the minus plus in the formula, it means don't use the same sign, use the opposite sign. And when you get down to tangent, notice in the tangent formula, you got a numerator and a denominator. It's got a plus and minus in the numerator, so keep the same sign of the sum or difference. And then in the denominator, use the opposite sign. And those formulas will change, whether you're adding two angles or subtracting two angles. Okay. Does anybody have questions on how those formulas are written? Okay, let's open up the first flap and do sine. Example. Find the exact value of sine of pi over 12. Usually when we're asking you about exact values, that's kind of a signal to say like no calculator. Although there are some angles that you could do in the calculator and you get the exact value, like it would spit out 0.5, you can just write that as 1/2. But more often than not, a lot of them will have radicals in them, like the square root of 3 and the square root of 2. And those things aren't going to come out exactly in your calculator. So now you need to use your sum and difference formulas. Okay, well if I ask you about the sine of pi over 12, you do not know pi over 12 on the unit circle. So we don't know its y-coordinate. That's too much to remember. Okay. What we need to do is think about angles on the unit circle that can either add or subtract to make pi over 12. Now, would you agree pi over 12 is a pretty small angle? So it's probably in quadrant 1. So I'd be thinking about some of those angles in quadrant 1. Pi over 6, pi over 4, pi over 3. And really to like figure out which ones add or subtract to make pi over 12, I probably want to have denominators of 12. Okay, so I could get common denominators for each of these. This would be 2 pi over 12, this would be 3 pi over 12, and this would be 4 pi over 12. It makes it easier to find the two angles that you want. Can you come up with two angles that either add or subtract to give you pi 12s? Give me a pair. Pi over 3 minus pi over 4 is what Liam said. If I had pi over 3 minus pi over 4 and I got common denominators, that would be 4 pi over 12 minus 3 pi over 12, which would be 1 pi over 12, right? Yeah. So I'm going to go ahead and write this as the difference of two angles, pi over 3 minus pi over 4. Now, some of you may have been looking at your choices, and maybe you were going to say pi over 4 minus pi over 6. Would that also work? Yeah, you can use either set of angles. It doesn't matter. We're going to come up with the same answer. So now that I have it separated into two angles, just assign them U and V. Now, one thing to note if you ever have a difference, these angles are always positive. So like V is not negative pi fourths, it's just pi fourths. The minus sign here just means use the difference formula, not the sum formula. Okay, so I'd flip over to the back side of my door and get that first part of my sine formula. What does it say? Sine U times cosine V. So plug it in. Sine of pi over 3 times the sine of pi over 4. Should I put a plus or minus?
Cosine.
Oh yeah, cosine, thank you. Second time today I did that, don't know why. Should I put a plus or minus? Minus. Keep the same sign. And then what is, your guys' says what? Sine V?
Cosine U.
Oh, cosine U, sine V. Okay, so we'll do cosine pi over 3 and sine pi over 4. Now, those are things you can evaluate from a unit circle, right? So, like, what is the sine of pi thirds? Radical 3 over 2. Cosine of pi over 4. I love a pi over 4 angle. That's square root 2 over 2. Minus the cosine of pi thirds is 1/2. And the sine of pi fourths is square root 2 over 2 again. So tomorrow when you come in to take your quiz, I mean, you should know your unit circle, right? Just because we're done with chapter 4 doesn't mean we're done with unit circles. So some of us need to practice that more than others. And then just simplify. You know, I got to multiply these fractions before I can subtract them. So just multiply across on top and multiply across on bottom. That's square root 6 over 2 minus, square root 6 over 4. Because I multiply 2 times 2. Minus square root 2 over 4. How wonderful, I already have common denominators. So this is going to be the square root of 6 minus the square root of 2 all over 4. It doesn't really get any better than that. I can't do square root 6 minus square root 2 exactly because those are not like terms. So that's its value. Now, if you were to get out your calculators and put your calculator in radian mode and then ask your calculator to do the sine of pi over 12, it will not give you an exact answer. It will give you a decimal that just like keeps going. If after you put in sine of pi over 12, you went into your calculator and typed in this expression down here at the bottom, square root 6 minus square root 2 all over 4, they would be the same decimal. So we've evaluated exactly. Okay, now let's look on the other side. Okay. We want to find the exact value of this expression. You see something like this, sine of 120 degrees, cosine of 60 degrees, minus the cosine of 120 times the sine of 60. What do you think you might do? What's that? Oh, what do you think you might do? What's that?
Change it to radians.
You could change it to radians. For what reason do you want to change it into radians?
more used to working with that.
Because you're more used to the radians. Okay, so if you wanted to, you could write it in radians. It would be the sine of 2 pi over 3 times the cosine of pi over 3 minus the cosine of 2 pi over 3 times the sine of pi over 3. Okay. Those say the same thing, right? We really haven't done much. What else can you do? Well, what does this look like? What's that, Brian? It looks like the same as the other one, so I'm going to flip back real quick on my slide. It looks like this stuff right here, right? Okay. So we see that it looks the same. We're being asked to find the exact value. How do you guys want to go about doing it, Dylan?
You just write like sine 120 minus 60.
Ooh, I really like that idea. Okay, so go back to this. We had expanded it all, right? So that matches this line here where we have like sine pi thirds, cosine pi fourths, all that stuff. But that came from some sum or difference formula. In this case, it was the two angles being subtracted. Okay, and so Dylan's looking at this next example, and he's saying, I'm taking a sine of u times a cosine of v minus a cosine of u times a sine of v. Isn't that just the sine of u minus v? So whether you do it in degrees or radians, it doesn't matter. That would be the sine of 120 minus 60, which is the sine of 60 degrees. If you're using Hannah's radians, you'd have the sine of pi over 3, right? Can you evaluate the sine of 60 exactly? Yeah, radical 3 over 2. Awesome. Did anybody have any other ideas for what they might do for that instead of doing the sum or difference formula? You could have just went straight into like the substitution from the unit circle. Like you know the sine of 120, you know the cosine of 60. You could have done all those substitutions and worked them out. They would have come out to be square root 3 over 2. But I do think Dylan's method is the smarter, not harder way. Okay, so if you ever see that where it's like written out, it looks like you already plugged it into the formula. Try to condense it first and see what that's actually equal to. Maybe you can evaluate it from there. Okay, let's do the cosine. This one's going to be a little bit different. It doesn't say find the exact value because you don't actually have two angle measures. In this case, one of your angles is unknown to you. It's theta, so we're going to call that u. And the other angle, in this case, we do know is 3 pi over 2. So we're just going to use the sum or difference formula. This is a cosine, so you're looking at that second door, and you're going to copy the cosine formula. So it starts off cosine u times cosine v. That's cosine theta times cosine 3 pi over 2. Should I put a plus or minus? A minus, because in the cosine formula, you got the minus plus over on the other side, so it mismatches. And then we're going to do the sine of u times the sine of v. Simplify what trig functions you can. You know, like if you're looking at cosine of theta, you don't know what that is until you know theta. But you do know the cosine of 3 pi over 2. What's the cosine of 3 pi over 2? 0. And the sine of 3 pi over 2 is -1. Well, in the front there, cosine times 0 is just 0. So 0 minus sine times -1, that's actually going to be positive sine. So this expression simplifies to actually just be the sine of theta. Now, This has a name. It says it over, I think, on the other side. It's called a cofunction identity. We're not ever going to like list out the cofunction identities and use them. You're only responsible for reciprocal, quotient, and Pythagorean identities. But what the cofunctions identities say is, like, if you think back to chapter 4, imagine I just graphed a cosine graph, right? Okay. Cosine graph looks something like this. Okay. And then on the other side, it would look like this. Okay, so this is cosine x. What this cofunction identity says is, because I put a plus 3 pi over 2 right here, that's like a horizontal shift. My b value is 1, so my period is still the same. And my horizontal shift would just be negative 3 pi over 2. If I take all of these points and shift them negative 3 pi over 2, what I'm going to create is a sine function. Actually, it should be right there. So then I'm shifting at negative 3 pi over 2 to the left, and now at the origin, it looks like Mountain High Valley left. So that's what those things are just asking you to do. They usually turn out to be just one trig function. Try the one on the next side for me. I think you have to verify it. So you already know what the answer is. Can you make the left side equal that? So I start by just using my cosine sum or difference formula. This is a difference formula, so I have to use the opposite sign in the middle. That will be a plus. Remember that your two angles, U and V, they're both positive. So you don't put in a negative x. You just leave it as x. And then evaluate. Cosine pi over 2 is 0 times cosine x plus sine is 1 times sine x. That should equal sine x. And sure enough, sine x equals sine x. If I ask you tomorrow in your quiz to prove a cofunction identity, make sure that you show the steps of the proof. You don't go straight to sine x equals sine x. Show through the values on the unit circle that they do actually cancel out. Okay? Any questions so far? Okay, we got one more to go. That's the tangents. Okay. Again, this first tangent example just to simplify the expression. So it's not saying find the exact value for a reason. You can't find the exact value when one of your angles is marked as theta. You don't know what that tangent's ever going to be. So we know that in the end we're going to simplify and there's going to be some trig function left over. So I would just flip back to the tangent formula on the front side. In the numerator, I'm supposed to do the tangent of u. Well, I do plus or minus here. Plus. Keep the same sign in the numerator. Okay, so this will be tangent of theta plus the tangent of 3 pi. And in the denominator, if you flip back to that formula, it says 1 minus plus. So in this case, we're going to do 1 minus. And then you're taking the other two tangents and multiplying them. So you have to multiply these two tangents before you subtract from 1 if you're following order of operations. Okay, we can't evaluate tangent theta, but we can evaluate tangent of 3 pi. There's a couple ways to do that. If you know where 3 pi is, you're good. Or you can think about coterminal angle. Coterminal of 3 pi is Anybody know the tangent of pi? 0. The ordered pair for pi is what? -1, 0. Tangent is y over x. That'd be 0 over -1, which is 0. So we have the tangent of theta plus 0 all over 1 minus the tangent of theta times 0. Well, down here in the denominator, 1 minus tangent theta times 0, that's just 1 minus 0. And in the numerator, we're just going to have tangent theta, so I will say that this just simplifies to tangent theta. And again, that's one of those what we call co-function identities, or the idea, if you think about it visually, of taking a tangent graph and shifting it, in this case, left 3 pi, it just maps onto itself. It's the same tangent graph. Okay, last one. This is the problem that most people have the biggest struggles with. So I make sure I'm like with it. On this example, we're going to talk about pros and cons, working smarter, not harder, how to pick the right angles. Okay? We're going to find the exact value of the tangent of 255. So I need you to think about some angles on the unit circle that add or subtract to make 255. 210 and 45. Give me some others. 120 and 135. I'll accept these two. Now there are other versions out there. You could do what? 300 minus 45. You could do a 225 plus 30. Okay, so like there's not always like we're all going to write the same set of angles, but this is a problem where I'm going to show you. You might wish to think smarter, not harder. Okay, so I'm actually going to work out both versions of these. I'm going to start by just plugging into the tangent formula. Okay. The one I like, if you care to only write one of them down, is 120 and 135. I'll talk about why I like that one better later. But if you want to write both, you can, or you can do one. Okay, this is going to be tangent 210 plus tangent 45 all over 1 minus tangent 210 times tangent 45. And this one, the formula is tangent 120 plus tangent 135 all over 1 minus tangent 120 times tangent 135. Holler at me if you notice that I missed a sign or an angle or something like that, because I made a sign error last hour, and I just don't think Emma will survive if I make a sign error today, okay? So I'm going to need you to yell at me if I make a mistake. Okay, right now, they look the same to me, right? I'm just doing some different tangents, okay? Let's start evaluating these tangents on the unit circle. What is the tangent of 210? Radical 3 over 3. And then the tangent of 45 is 1. And then this would be 1 minus radical 3 over 3 times 1. So then I'm going to go ahead and simplify this once more. Square root 3 over 3 plus 1 all over 1 minus square root 3 over 3. Okay. On the other side, what is the tangent of 120? Negative, because it's in quadrant 2, and radical 3. So this is negative radical 3. The tangent of 135, also in quadrant 2, this is negative 1. All over 1 minus negative square root 3 times negative 1, which this will simplify to be negative square root 3, I'm going to say minus 1, all over 1 minus square root 3, because this will multiply to be a positive. That's where my sign error was last hour. And evaluate it. Okay, now at the point where we're at, does one look better than the other? Yes. Okay. So if I could give you a hint to working smarter, not harder on tangents. Do not use angles that are of the pi over 6 or 30-degree reference angle family. So don't use pi over 6, don't use 5 pi over 6, don't use 7 pi over 6, don't use 11 pi over 6, don't use 30, 150, 210, or 330. If at all possible, if you can come up with 2 other angles, it will be easier because you won't have those fractions inside of fractions. Okay? Now, we're technically not done. I'm going to work on the one I like, the one on the right. We're technically not done because remember that old school rule, you're not allowed to leave a radical in the denominator. The rest of this is just simplify. Okay? So the big question is, how are we going to get a radical out of the denominator? When you have 2 terms that are being added or subtracted, this is kind of harkens back to complex numbers when you had i's in the denominator, you use the conjugate. So if we want to get rid of 1 minus square root 3, we're going to multiply by the conjugate 1 plus square root 3. And we have to do that on the top and the bottom. Okay. So we're a lot of times on this tangent because there's always going to be the 1 minus the product of the tangents. A lot of times there's going to be this radical down in the denominator, so we're going to want to get it out. Multiply by the conjugates. It's all foiling. The radicals in the denominator should cancel. You'll probably have radicals left over in the numerator, and you'll just be combining like terms. So I'm going to FOIL my numerators. I'm going to start with the negative, you can put a parentheses around it if you want, negative square root 3. Negative square root 3 times 1, and negative square root 3 times square root 3. And then I'm going to take the negative 1 times 1, and negative 1 times square root 3. Those are my 4 terms in the numerator. You okay with that? A square root 3 times the square root 3 is just 3. Okay, in the denominator, 1 times 1 and 1 times square root 3. And then negative square root 3 times 1 and negative square root 3 times 3. And this is exactly what I wanted to have happen in the denominator, right? Plus square root 3 minus square root 3. Yay, I don't have any radicals in my denominator anymore. That makes me very happy. That's called rationalizing my denominator. So now it's just a matter of combining like terms. In the numerator, I have negative 4, and then I have a negative square root 3 with another negative square root 3. Well, that means I have negative 2 square root 3s. All over 1 minus 3 is negative 2. Okay, and the last thing I can do is simplify any of the numbers that are all outside the radical, as long as I can simplify all 3 of them. Well, they all have a factor of 2, and they're all negative, so I could really make them all positive. So this is really 2 plus square root 3. Now, if you have some angles that, or you're finding the tangent of some angle formed by some 60 degree and 45, you're often going to get this like 2 plus square root 3, 2 minus square root 3, negative 2 minus square root 3. Like you're going to keep seeing the same answers, just like we always did with the unit circle, right? Because there's only so many numbers at work here. Real quickly, should you ever find yourself in a pickle and you chose pi over 6 or 30 degrees, there is a way to kind of dig yourself out of this hole, make yourself your life a little bit easier. I mean, you could do the conjugate here, right? But you can imagine that's a lot of fractions and radicals to keep track of. So in a bad situation where you've chosen this and you can't think of any other angles that will work, to get rid of the fraction, just multiply by the denominator. So multiply by 3. And of course, to keep equality, I have to multiply by 3 over 3. So I'm really multiplying by 1. And what that does is that gives me square root 3 plus 3 over 3 minus square root 3. So notice I don't have the 1s anymore. I have 3s, where up here I have 1s with my other nickel. But if I now choose the conjugate and do all the FOILing, I'll get 2 plus square root 3 as well. So that's a way to kind of dig yourself out of that hole. If you get yourself in a hole, just multiply by the denominator. It'll cancel it out. But you have to multiply the 1 by the 3 too. Okay? Okay, so you have a homework assignment this evening. It's on your gold sheet. I would definitely take the time to do these problems on the homework assignment so you're comfortable with looking at formulas and using them, because that's what I'll expect you to be doing on that part of the quiz tomorrow. And then some of us have maybe slacked off a little bit on that section 5.3, solving trig equations. There's going to be some of the more complicated solves on there. So you got to know how to substitute your identities to get all the same identity. Or you've got to be able to factor a trinomial with trig functions in it. So, go back and retry those examples from our notes. Pick some of those out from the homework assignment. Come in and get the help that you need, but those will be included on that quiz tomorrow. Okay? And then after the quiz, we are going to take notes over some other formulas.